We talked about you real bad before you got here, though. All right.
Is he talking to me?
Yeah, Miss Castles.
I texted you and told you I was going to be late.
I know. I tried to call you a couple of times just in case, but I just told them to holler whenever you got here. So they said that you were on campus, so you're here. Thank you for showing up.
Okay.
All right. From 0 to 1, x to the second minus 3x plus 5 dx. This is a definite or indefinite interval? Definite. Why? Because it has parameters. Your lower limit is 0. Your upper limit is 1. Here is a picture. Should you look at the picture? Yes, you should.
My screen froze. Could you call me back in a second?
Say again?
My screen froze. I'm going to leave the call. Can you give me a call back?
Was that Mr. Howell?
Yes, sir.
All right, X out, and I'll bring you back in. The things I do for y'all. Need to get me some dang posters. Howell, there's Mr. Howell. There we go. Okay, so it would behoove you to draw a picture when possible. And you see, there is the area. The area, and we can see there's 1, 2, 3, 4, 5, 6. There's 12 right there. 13, 14. That one makes 14 and 15. So it's about 15 square units. But let's see how much it really is. Now, you could do Riemann's, and I'm just going to give you a little rundown of what Riemann's is. Do y'all remember how the difference quotient was the predecessor to finding the derivative? And y'all know how aggravating the difference quotient was?
Yes.
It made you appreciate the calculus. Well, the Riemann's sum is the same thing as the difference quotient. It shows you how you should embrace the antiderivative and say, I love the calculus because I don't want to do all this math. Okay? Riemann's sum, basically, you can do the left or the right or the midpoint, but you take this guy and you drop a midpoint, and that's what, 0.25, let's say that's 0.12, and then you drop a midpoint here, and then that's 0.75, and then you drop a midpoint here, and that's 0.62, and then you drop a midpoint here, that's 0.8 or something, and then you take those midpoints, and then you multiply by that midpoint plugged into the formula right here. So what is, I wish I didn't pick those decimals, but you don't have a choice. 0.12 or 0.1. If you plug 0.1 in here, you would get a height, right? And that height would represent this point right here. And then you would multiply that, you would add it to this, add it to that, add it to that. And you would add those 4 rectangles together, or they're not really rectangles, they're midpoint rectangle estimate. And then you would add those 4 together. Does everybody understand that?
I don't really understand why you're doing that.
Say again?
I don't understand why you're doing that.
Why, well, you don't really, why I'm doing this right here.
Yeah, I don't follow the entire problem, actually.
Well, what is the area of a rectangle? Length times what?
Base times height.
Length times width, or base times what? Base times height. So if I want to find the area of the yellow region, would you not say I have 4 rectangles there?
Yeah.
Okay. Let's take the width of this rectangle. The width of this rectangle is 1/4, right? This is 1/4. This is 1/4. This is 1/4. Everybody agree with me?
Mm-hmm.
Okay. What's the height? Well, you got to take 1/4. So I want somebody to take 0.25 and plug it into this formula, do that. Go ahead and take 0.25 and plug it into that formula and see what you get. And then 0.5, and then 0.75, and then 1. Okay? So somebody put 0.25 in this formula. F of 0.25, F of 0.5, F of 0.75, F of 1. I'll do F of 1 for y'all. That'd be 1 minus 3 is negative 2 plus 5 is 3. I think that's right, isn't it? So that's 3.
Positive 2.
Okay, so the area of this guy is 3. How many squares are in that yellow region right there? 3. Okay? What is 0.75 in the formula? What is that? Somebody plug it in.
3.3.
3.3. And somebody plug in the other. 0.5.
3.75.
3.8. And then somebody plug in 0.25. I'm sorry, what?
4.3.
All right, add those up. Take the first rectangle plus the second rectangle plus the third rectangle plus the fourth rectangle. I said this is around 12. I mean, not what I say, 12. That's 12, 13, 14, 15. I said around 15, didn't I? What is it?
14.375.
I'm sorry, what?
14.375.
So with Riemann sum, that's equal to 14.35. Riemann sum, what's the S stand for? Sum, meaning you're going to add all of those rectangles up. Is it space shuttle work or is it guesstimating?
Yes.
It's guesstimating. So who asked that question? Was that Miss Uyabi?
Yeah.
Does that make better sense now? You're just basically adding up all the volume, the areas of the rectangles. Do you see what I'm saying?
I mean, I understand what you were doing. My question was why you're doing that. Like, how does that relate to the problem?
Well, do you remember how the difference quotient was a pain in the rear to do before the derivative?
Yeah.
Okay. Well, Riemann sum is a pain in the rear before you do the antiderivative.
Okay.
Do you see what I'm saying? In other words, you're going to say, God, I'm glad we don't have to do Riemann sum. Because what if I made each one of those yellow boxes, those rectangles, what if I made them the hair, width of a hair?
Right.
How many could fit in those 4 boxes if it was the width of a hair? Infinite. Then how are you going to do summation k equal to 1 to what? To infinity. How are you going to do that? It's impossible. So that's why we have the calculus. Now, I did spend a lot of time going through the difference quotient so you would appreciate the derivative. But I'm not going to spend that much time in Riemann sum because 1, we don't have a lot of time, and 2, it's basically to show you how to appreciate the antiderivative. Okay? So we know by counting the yellow boxes that we got an area around 15. We just did a Cliff Notes version of Riemann sum, or Riemann, depending on who, whatever. And we've got an estimated area of 14.35. The real detailed area is the antiderivative. That is your real detailed area. So how do you do it? Well, we already did a couple. You could actually break this up into the antiderivative from 0 to 1 of x squared dx minus the antiderivative from 0 to 1, put the 3 out front, x to the first power, plus dx, plus 5 antiderivative of dx, and dx has a 1 in front of it, like that, from 0 to 1. Now that is the property. Okay, that is called the sum property. Okay, I'm not going to spend a lot of time going over it. It's just that if you have 2 or 3 terms in a polynomial, you could break each one of them up, if you wanted to, into separate what? Antiderivatives. You don't have to do that. That's just something I want you to know, because that's how we do it. So this first one is going to be x cubed over what? 3 minus 3x squared over what? 2 plus 5. This will be x to the what? This is an x, it's x to the 0, which would be x to the first over 1. And that's evaluated at 0 and 1. Okay, who's got questions?
What did you do there?
Remember, we did this the other day. What do you do to the antiderivative? You add 1, and then the fraction, you bring that down. You add 1, fraction, bring that down. You add 1, this is x to the 0, you add 1, bring that down. You remember us doing that the other day?
I wasn't here the other day. I'll watch the video.
Okay. All right, so that's the antiderivative. Now you got to evaluate. Evaluate means plug and what? Plug and chug, Hubert. And I can't move any of this stuff. I just want to move this. This is all I want to move, is this side right here, and it won't let me.
Why did you put that x there? That x in front of the d?
Where?
As the 5 in the integral of the x.
Because
Remember the first week of class. I told y'all, when something is missing, you plug it in. I've got x squared. Hold on a dang minute. I've got x squared minus 3x plus what? 1 plus 5. Okay? Fill in the blanks. This is x to the second power. This is x to the first power. And what is this? X to the what? 0. Remember me telling y'all that when we started derivatives?
No.
Yes, no, maybe?
Yes,
Thank you, one person.
And you just pulled that constant out and put it in front of the
Constants
number.
always come out front. We said that. Was it yesterday when we said that? Constants come out front. Just like a derivative. Now I'm gonna erase that because I don't have room and I can't shrink it. So
What's
I'm
that
gonna
line
just
that
erase
you put
this.
right there? Put the 1 and the 0 next to it.
it means evaluated, like those two numbers.
That don't mean anything. I don't mean any harm, but if you miss a day, you need to watch the video. Please. Okay. Now, I'm going to rewrite. Now, this is the way I do it. Now, I know there's water walkers, and I know there's people that do things different. But if you came into my class, and I wasn't teaching you calculus, and you came into my class and you said, Hubert, will you do this antiderivative? This is the way I would do it. I did it like this when I was a student, and I keep doing it this way. So those of you that don't need it, well, more power to you. So I rewrite the problem, and I put parentheses in. Until you practice enough, this is what I would suggest. And then I put a bracket there. And then I minus, because this symbol right here means minus. We went over that yesterday. And I rewrite it, parentheses cubed over 3 minus 3 times parentheses squared over 2 plus 5 times parentheses. Now, what am I going to plug in first? I'm going to plug in the 1 because it's the highest number. Well, let me do this, because since I don't have any posters. There. And then the 0 is red. Plug that in right here. Now, what's great about 0?
It cancels out.
It cancels everything out, so you can just go ahead and cancel all this out. Okay, that goes to 0. And therefore you're left with this. So, 1 to the third power is 1, that'd be 1/3. Minus 3 times 1 is 3/2, or 3 times 1 is 3. To the third power is what? Second power is 9. That's 9/2. Plus 5/1. And now we got to get a common what? Denominator. So I'm going to put a 15 here. I'm sorry. A 6.
Wouldn't that be 3/2 instead of 9/2?
Yeah, because I have
Do the
the
exponent first before you multiply.
Okay, 3/2. Thank you. Okay, now 6, 6, 6. And 3 will go into 6. 2 times 1 is 2. 2 will go into 6. 3 times 3 is 9. 1 will go into 6. 6 times 5 is what? 30. What's 2 minus 9? Negative 7 over 6 plus 30 over 6. What's negative 7 plus 30? What?
23.
23 over 6. How many times will 6 go into 23?
1.
Huh?
No. 3.
3 times? We've done something wrong. 3 times 6 is what? 18? Yeah, we've done something wrong. It's supposed to come up with 14.35 or 15. We've done something wrong. Check my math and check my calculus, because we've done something wrong. 23/6 comes out to be 3. 3, 18, 18 to, what is 5, 6? 3 and 5, 6. Well, that's not right. Because we all see that there's 15 units in there. Check my math and make sure I haven't messed up somewhere. I know that's not right. I'll type it in, but I know that's not right. Unless wait a minute. These are wait a minute. Okay, I'm sorry. I counted those blocks as 1. Those blocks are not 1s, are they? Are they 1s? They're quarters. They're quarters, yeah. So that's not going to be. So that's not 15 and 14.35. Let's go back. Let me erase that. And I was doing it wrong. I'm sorry. I was thinking that each one of these blocks were 1. So my bad. So we have to go through. Let's see, this is 1. This is 1, 3, but these are quarters. So this is 0.25. So 1 times 0.25. So these, if you add these up, it should equal this. My bad. I thought one of these was 1. I'm sorry. So the quarters, that's 1, 2, 3. There's 3 units right there. And then there's a half right there. And this is, I'd say that one and that one is maybe 1. So it's almost 0.75. Almost 3.75. What is 3 and 5, 6? What does 3 and 5, 6 come out to be?
383.
3.8?
Yep.
Okay, well, we see that if I read I wasn't even thinking when I did it. This is 1, this right here is 1, this right there is 1, that's 2 because these are quarters, and that's 3, and then that's a half, and then this right here is almost 3.75, so we got 3.83. And that's how you do the antiderivatives. Let's do another one. Now, I don't know what they want as an answer. I don't know if they want 3.83 or 26. I'm going to type in 23 sixths, and let's see what we get. 23 divided by 6. That's what they want. And I really don't care what they ask you after that. Is your result? Yes, it is consistent. If you count the blocks the way you're supposed to, not like I did. My bad. Let's do a nerd. I don't want to do signs yet. We can do signs later. I'm worried about basics right now. All right, there's a nerd. Now this one don't have 0 in it, so you're gonna have to do more math on this one. So I'd probably just quit. This one says the antiderivative from -3 to 1 of x squared plus 2x minus 3 dx. I'm going to give y'all a minute to get it started. And then I'm not going to break it up. You can break it up. It'll be the antiderivative of x squared plus 2 antiderivative of x minus 3 antiderivative of 1x to the 0. If you want to do it that way, that's fine. I'm going to just go to the next step. Now, did you say the short guy got a new girlfriend, or?
That poor girl.
Yeah, that's what I said. That's what Miss Brudiker, you said that he's got one? Yeah. Since the video, he's got a brand new girlfriend.
Probably hates her.
You're talking about indicators out to yin yang. You know, the ones I talk about, you know, the one where they have to take a picture of their toy with them on Facebook, or they wear sunglasses inside, or that. Oh God, he's filled with them. I would tell any girl to run like hell away. Okay, this agent app is getting on my nerves.
Everybody's talking about that lately.
Oh my gosh. People grow up. Well, my son did mine last night, my picture. And at least by the face app, my hair's not turning. I'm gonna have a more silver beard and still have black hair. So I'm gonna look really strange. So better than not having hair. I'll take my hair no matter what color it is. Okay, y'all. Thank you for your interaction.
Welcome.
Yeah, now people are taking pictures of their girlfriend and making the girlfriend look old. Oh my gosh, I'm not even going there. Damn Russian apps. Okay, so what is the antiderivative of x squared? X to the third over 3.
Three.
Or 1/3 x cubed. what's the derivative of 2x? 2x squared over 2.
2x.
Now, you can cancel while you're doing it, but some of you that are crawling, you might want to just wait a while before you start doing all this canceling, okay? Just saying. 3x, this is x to the 0, this is x to the 1, so that's going to be x to the 1 over 1. Evaluated at -3 and 1. So I'm going to go over here, and I'm going to do cube over 3 plus square, because the 2's cancel, minus 3 parentheses, minus bracket, and I always do this, I always put brackets on there just in case, and I'm going to rewrite it. I wonder if I can do this, since I don't have a poster. Oh, hell no, it's not going to let me do it. Oh. Parentheses cubed over 3 plus parentheses squared minus 3 times parentheses. And I'm going to plug in the top one, which is a 1. I'm going to plug that in right here. And I'm going to plug in a red -3. I'm going to plug it right here. All right, go to work. Impress me. I want to see if y'all can do, without a calculator, I want to see if you can actually do the fractions of that mathematical problem. I hope all of you can. But if you can't, just consider yourself a failure in life. You know, this is a pretty good class. I don't think I've had anybody, I think I've had one person drop. That's pretty good out of a calculus class, isn't it?
I mean, aren't we all going to fail anyway?
Yeah, but might as well I always try to keep y'all's hopes up, because that's the best time to crush you, is when you got your hopes up. So you're going to be all happy, you know, walking down the hall thinking you got an A in the class, and then you're going to go to the registrar's office to transfer, and it's going to be a big F. So, because I don't like y'all, because y'all wouldn't interact with me.
Yeah, I know, we suck.
Yep, there you go. You're getting it. It's only taking y'all all semester to figure that out. So we got 1/3. So I'm going to go down here and I'm going to do 1/3 plus 1 minus 3 brackets minus brackets. -3 to the 3rd power is going to be -27 over 3 is negative what? 9. -3 to the 2nd power is positive what? 9. And -3 times -3 is what? So what happens to the two 9s? They go out. You're left with -9. So this looks like, somebody check my math, this looks like 1/3 plus 4/3 minus 9/3. And that negative is going to make that, so I'm going to just put that right there. And that's going to be minus 27/3. And what's 1 plus 4 minus 9? 1 plus 4 is 5. 5 minus 9 is -4/3. Minus 27/3 is equal to -31/3. Now, area cannot be negative. So what does that mean? Golly, is there a storm outside?
Yes.
Wow.
Yeah, there is.
Dang old trees, dang old bending, dang old tornado. Negative means that it's below the x-axis or it's over on the other side of the y-axis or whatever. Okay? So if you was to actually graph this and you was to go from -5 Because the y-intercept, somebody tell me what the y-intercept is. -3. So you know that the y-intercept is -3. Where is this area from 1 to -3? -3 is right here, and 1 is right here. You know there's some kind of area, and it's under what? The x-axis. I don't know what it looks like. You'd have to draw it. I don't know. But the negative means that it is below. So it should be, unless I've done something wrong. Check my math. We're fixing to punch it in. -31/3. So negative, put the negative in front of the fraction. 31/3. Oops, we must have done something wrong. Let's check it and see. Let's see what they got. What did they get? Okay, -32/3. I must have done something wrong. Somebody check my math. 1 + 4 is 5. Right?
It's at the very end when you converted the 1 to 1/3. It should have been 3/3
Okay.
instead
Thank
of 4
you.
over 3.
Thank you. 4/3 or 3/3. I don't know why I did that. Thank you, ma'am. So that would be 32/3. Okay? Now, there are some teachers that will not ask you to do the math. They'll just ask you to set it up, and this is the setup. So I need you to highlight this right here. Oops. Highlight this and call it the setup. Because sometimes they will ask you just for the setup. And so far, these last two questions that we've done are real good test questions because that's what I'm going to give you on the homework when I make out the homework. All right? Yeah, this one will make you quit. Oh, double whammy. Why will this one make you quit? You got a fraction on the integral and you got a fraction as a boundary. So yeah, half of y'all ain't even going to do it. Right? There you go. So this one says, and you know dang well this is going to be a test question. Heard somebody. Damn it, bastard. 2 1/2, or you can do 0.5 if you want to, but it's easier to do 1/2 because you can do basic math. Of 2 minus x, 2x to the what? -2 dx. Why did I do that? Because you don't want a fraction, you need to rewrite it. Remember, fractions and radicals, you need to rewrite them. So I'm going to let y'all do this one. Now that 2 by itself, that's 2x to the 0. For those of you that are still crawling. No yawning in class. Hurt my self-esteem and I might go bagel shop on you. Okay, nobody's going to talk. This is the quietest dang class I bet I've had in the last 5 years. Y'all proud of that, aren't you? Proud.
I feel like we should get a trophy.
Yeah, everybody should get a trophy. Don't get me started on that. Everybody feels good about themselves.
Well, we've accomplished something that no one has in 5 years.
What's that?
Being the quietest class.
Yeah, made me feel uncomfortable, inadequate, and made me feel insecure as a math teacher. Yeah, thank you.
Technically, wouldn't that be workplace harassment?
No, I'm gonna get me a gallon jug of water and carry it around so people know I work out. That's what you're supposed to do, ain't it, guys? Nobody's gonna say.
Yup.
Yep. Or I could buy toys I can't afford and pose with them on Facebook. That's what I could do. Or I could just go bully everybody in the bagel shop. Bagels. What the hell is bagel? Bagels are the nastiest thing ever made.
What is?
Huh?
I can't agree, baby.
Oh my gosh. You can't compare a bagel to a biscuit. I mean,
It's a biscuit.
everybody eats a biscuit. You need, okay, you're gonna fail this class.
All right, I'll fail this class.
You're gonna fail it. Where you from, boy?
New Jersey.
What?
New Jersey.
Oh, that's
Okay,
why.
well, you have a right to say that. But trying to put bagels in South Carolina is trying to put hockey in South Carolina. It don't work. Kringle's done tried it how many times? 5 times, and they can't give away the tickets. How long you been down here from New Jersey? Okay, well, you don't count then. What were you what were you in a stroller when you came down here? How long?
2000, I think.
Okay, so you've been down here
A while.
a while. Anybody else from New Jersey? They ain't gonna talk.
But I went to school in Philly, so I got used to some bagels.
Miss Sword, be quiet. We don't want to hear from you.
But they still ain't got nothing on biscuits, though.
I'll be honest with you, if you raised on biscuits, I don't see how you could ever eat a piece of cardboard pertaining to a biscuit.
I mean, I like turning my mouth into the Sahara Desert as well.
Okay, well, you think that's it. You haven't had anybody that actually knew how to cook biscuits.
I guess not.
Yeah, you probably got those things in the grocery store. What do? You bust them up against the, and no, them things are nasty. Yeah, you need to. If you ever ate a good old Southern biscuit, you would. It ain't dry. No, it ain't dry. Okay, nobody's gonna say anything. I'll just keep going. All right, so 2x to the 1 over 1 minus 2x to the negative 1 over what? Negative 1. Evaluated at 1/2 and 2. Now, before you start this, you need to simplify that a little bit. That 2x is going to be a 2x. But what happens with that negative 1? What does that negative 1 do to that negative 2? Not a negative. It makes it a positive, and then the x to the negative 1 comes what? Down. So you need to rewrite this, and that's going to be 2x minus, be a plus, 2 over what? Evaluated at 2 and 1/2. So I'm going to rewrite 2 parentheses plus 2 over parentheses, brackets, minus brackets, 2 parentheses plus 2 over parentheses, brackets, and that's my 2 right there, and my 1/2 right there. You do not need a calculator for this. If you need a calculator for this, you might as well say you can't spell mom or race car backwards. Okay? So, let's do it. 2 times 2 is 4.
Oh my God.
You just now figured that out. Race car backwards is race car.
I had not heard that before.
But don't feel bad. I didn't know chest of drawers was chest of drawers until about 3 years ago when I was moving stuff out of my house. Somebody called it a chest of drawers, and I thought it was Chester drawers. Chester. So, not all of us walk on water. Minus, what's 2 times 1/2? And what's 2 divided by 1 over 2, which means multiplied by 2 over 1. Four plus 1 is 5. 1 plus 4 is 5. Now, let's talk about this. What has happened when you get an area of 0? Does that mean that the space-time continuum has collapsed on itself? No, it means that you have symmetric areas, one above the x-axis and one below the x-axis. And what do the areas do? They cancel out. Make a note of that. When you get an area of 0, that means symmetrical cancel. Not cancer. Symmetrical cancel. Symmetrical cancel. Meaning that you have one that's positive area, that means above the x-axis or across the origin, versus the same area that's below. Let me give you an example of what I'm talking about. This is about the origin. You got this area, and then you got this area. And what do the areas do? The one has an area of 2, the other has an area of -2. But since they are about the y-axis, they cancel out. And that's what this happens. That's what happens when you have a 0 for an area. So if you were to graph that, you would see it. So let's take a minute and graph it. Let's put 0 to see if we made, anybody seen any mistakes? Oh, shut up. I don't know who that was. Let's see. 0. And we feel good about ourselves. Now, okay, they're showing it. Oh, well, that's nice. Okay, so, but we still need to, you're looking for symmetrical, so let's pull up the graph. That's a good test question because it actually asked you that, so that's good. Somebody give me the function. What is, oops, sorry. F of x is equal to what? Don't give me the decimal, give me the negative exponent. What is it?
2 minus 2x to the -2.
2 minus 2x to the -2. And hit graph. And from negative, is that what it looks like? Let's see what they got. Pull up the problem. Okay, it's on the right side because they're going from, on the positive side, they're going from 1/2 to 2. So from 1/2 to 2, there's 1/2, 1, 2, here it is. It's this one right here. It's not symmetrical, but it can pertain to symmetrical. Most of the time it's symmetrical. Some of the time it's the skinny one versus a shorter one, or a longer one versus a shorter one, or whatever. So I would say C. Okay? Now this is a good one because this is a good test question because we got 10 minutes for our, what is it, 4:20 when y'all get out, or 4:25?
25.
Okay. So y'all telling me the truth? Miss Rudiger, is she telling me the truth? Okay.
Yeah, it's 425.
Okay, just want to make sure. All right, so here we are, 4, from 2 to 4, 4x to the third, plus 9, dx. Give y'all a couple of minutes.
If I was lying, why would I give you the later time?
What?
If I was lying, why would I give you the later time?
Well, I didn't know if it was 4:25 or 4:30. I didn't know. I was at boot camp with a guy from Long Island. Is that near No, that's near New York.
Are you a co-op?
What?
I'm being stupid.
He was from Long Island, and he was a strange character.
We're all strange.
Actually, me and my son took a train ride up there last summer vacation or 2 summer vacations ago, and we spent a week in New York. Right down from what's the Union Station? Is the Union Station where the train goes? I think that's it. Right down the street. And I will never go to New York City again in August. There is no way in Hades I will do that again. We about had a stroke on the dadgum boat that goes out to the Statue of Liberty. Everybody was on there, about 500 people on that boat, and they all stunk because it was so hot. I know I was also probably pretty hot too.
New York just smells bad in general.
Actually, I'll be honest with you, I was very surprised. I was very surprised how nice it was as far as people. They were very nice. Maybe they just knew that I was a redneck from South Carolina and they thought they might not be nice because I might go postal or something. I don't know if they thought that or what. I don't know. You know how dumb, racist, ignorant Southerners are. Went to, what's that park called? Central Park there. We beat up a couple of people and took their bicycles away from them. Rode around Central Park for a while.
Nice to see you're embracing culture.
Yeah, I taught my son. He was only 10 at the time, but he took that girl out one whack. We're doomed. 4x to the fourth over 4 plus 9x to the first over 1, evaluated at 2 and 4. And the 4's go out. That's going to give us x to the fourth plus 9x, evaluated at 2 and 4, parentheses fourth plus 9 times parentheses minus brackets, parentheses to the fourth minus 9 times parentheses. Oh, this one's too easy. I'm not going to give you this one on the test. I'll probably mess it up. 4 to the fourth power is going to be 64 times 4, which is what? 216? I have no idea. What is it? 256 or 216? What is it? 256 plus 36 minus 2 to the fourth is 16 minus 18. Y'all check me. And that's going to be 256, dang old 292. And this is going to be a negative 2, which is a positive 2. I got 294. What'd y'all get?
Plus 18.
Is it plus 18?
Yeah, it should be 16 plus 18.
Where'd I get
So
the
you should
minus
get-
from?
You did negative 9 times 2.
Huh. I don't know why I did that. Okay, thank you. So that would be minus, so it'd be 290. Now, I
It's
don't mean
258.
hard. What?
It's 258.
Oh, then 256 plus 36, what does that come out to be?
292.
Oh, I'm sorry. Okay. What's 16 plus 18? 34?
Yeah.
Sorry about that. 34. and that's going to be 326. What y'all say?
No, it's subtract. You subtract the 34.
Subtract. What does it come out to be? I'm ready to go. What is it?
258.
258. Thank you. 258. Now, you can't complain. These are not that difficult. Are they going to get much harder? Yes. Now, we're only supposed to go to substitution in Calc 1. Calc 2, you're going to start out with it. You're going to start off from substitution. You're going to move into ultraviolet minus voodoo. You're going to go into the trigonometric functions, the inverse trigonometric functions. So that's where you're going to start in Calc 2. And ultraviolet minus voodoo, I'll show you what that is when we get into substitution either tomorrow or the next day. I'm going to try to put up some homework tonight. I might put it up separately, 5.3 and 5.5, so y'all go ahead and get started. But most of them will be like this, but they will get a little bit more challenging, okay? Questions? All right, y'all get out of here. Have a good day. I know who's here. Y'all get out of here. See y'all tomorrow.
Reagan, what are you doing today? I'm actually going to clean. Oof.